Hello learners of all ages, my name is Mr. Montgomery. I teach 4th and 5th grade math, and today we're going to be talking about multiplying fractions and whole numbers. So as you can see behind me on the board, I have 9 times 1/4. I have a whole number times a fraction. Well, we can't multiply fractions unless both of the numbers are fractions. So I have to change that whole number to a fraction. The trick is that I can have any whole number be put over the number 1 and it turns it into a fraction. So I have 9 over 1 times 4. You might be wondering, Mr. Montgomery, how does this work? Well, remember, fractions are essentially division problems. So I could take 9 divided by 1 to double check to see if it still has the same value as 9. 9 divided by 1. How many times can 1 go into 9? 9 times. 1 times 9 is 9. I subtract. I get 0 as my remainder. I use the popcorn method. 9 and 0 over 1. 9 and 0 over 1, well, if I have 0 over 1, that has no value. So my answer is 9. 9 over 1 still has the same value as 9. So back to the problem that we were working on. I have 9 over 1 times 1 over 4. Well, I multiply just straight across. 9 times 1 is 9, and 1 times 4 is 4. Now you notice that we have an improper fraction where the numerator is larger than the denominator. What method do we use in order to change an improper fraction to a mixed number? That's right, the popcorn method, or the divide and popcorn method. So we go take 9 divided by 4. 4 can go into 9 2 times. 4 times 2 is 8. And if I subtract, I get 1 as my remainder. Pop and top rhyme, so we're going to start from the top, go to the bottom, and off to the side, make it look like a popcorn piece. And I have 2 as my whole number, 1/4 as my fraction, and 1/4 is simplified, so 2 and 1/4 is my answer for 9 times 1/4. Let's take a look at another example. I have 6 times 3/5. Well, very first thing I'm going to be putting 6 over 1 times 3 over 5. That way I have 2 fractions that I can multiply together. 6 times 3 is 18, and 1 times 5 is 5. I have an improper fraction I need to divide, and popcorn method. So 5 goes into 18 3 times, because 5 times 3 is 15. And if I take 18 minus 15, I have 3. So I'll start pop and top right. Start at the top. 3 and 3/5. 3 and 3/5 is my answer. Now what if I have a problem that looks like this? 2/7 of 14. Or in this case, it's $14. If you take a look at the multiplication section of our bulletin board over there, you'll see that the word of is associated with the functionality of multiplication. So I have 2/7 times 14. Well, 2/7 times 14. And because the commutative property says that I can flip them around, that looks a little bit more familiar with what we're working with. First things first is I take that 14 and I put it over 1. Now I have 14 times 2. Well, 14 times 2 is 28. And 1 times 7 is 7. Now I have to divide and popcorn method. 28 divided by 7. 7 times 2 is 14, and 14 plus 14 is 28. So that's 7 times 4. 7 times 4 is 28. And I have 0 left over. Pop and top rhyme, so I'm going to start with the 4. Go to the 0 and 7. I have 4 and 0/7, but I don't leave the 0/7 because 0/7 does not have any sort of value because it's 0 out of 7. So my answer just is 4. Okay, you got me. When it came to 4, I forgot one thing. And I'm a stickler for this with my class, and I forget from time to time too. Thanks for catching my mistake. It's not just 4, it's $4. Let's take a look at one more example that you might see on your homework. I have 7 times n equals 7/12. Now we have a variable thrown in, which means we don't know what it is right now. But if we work by filling in the puzzle pieces or even work backward, we can probably figure out what n is. So the information I know is that my answer is 7/12. And I know that it is equal to something on this side. Well, we know that when we multiply, we're going to take 7 times 1 times something. So we're getting from 1 to 12. And the only way that we can get from 1 to 12 is if our denominator is also 12. And we're going from 7 to 7. Well, the only way to get from 7 to 7 with multiplication is to multiply by 1. So let's just double check. 7 times 1 is 7. 1 times 12 is 12. So n equals 1/12. Now, if I'm taking a look at another example, I have 3/10 of $50. That could be written as 3/10 multiplied by 50 over 1. Now, we're starting it up into some pretty large numbers. I technically could solve it like this. 3 times 50, that's 50, 100, 150. And I have 10 times 1 is 10. I could simplify here, but I also could have simplified starting over there, but we'll get into that in just a little bit. I have simplification of this one, and I have 15 over 1. So 15 over 1 is equal to $15. Now, another way that I could have done it is I could have done something called cross simplification. Whenever you're working with two multiplication of fractions, you can simplify even before you start multiplying to make the multiplication part a lot easier. A lot of fifth graders don't know that how to multiply 50 times 3. But I see that this ends in 0 and this ends in 0. I go diagonal. You know how the multiplication symbol goes diagonal? We can simplify by going diagonal. So 10 and 50 can be simplified by dividing each side by 10. Or I can just write it like this, divide by 10 and divide by 10. This only works when you cross diagonally. Now, if I look at 3 and 1, I can't simplify 3 and 1. So my new number for multiplication would be 3 over 1 times 5 over 1. 3 times 5 is 15 over 1, which is equal to $15. And the last type of problem that we're going to be running into is something that's not found in your practice or not found in any of the instruction in the book. They're just trying to have you piece the pieces of knowledge that you know in order to problem solve. This is a little bit higher thinking. Now, this is an example under your homework on on number 12, page 130. We have half of something is 5. Now, of, again, means multiplication, so I can potentially write 1/2 times something equals 5 over 1. Or another way to write it is something, we know that's going to be a whole number, times half equals 5 over 1. Now, we know that this is going to be over 1, because we know that for this lesson we have a whole number times a fraction. Well, what is half of 5? Or another example is, I can take 1 times 2, I know that's going to be 2. So I need half of a number to get me to 5, because I know that my whole number is going to be 5. Well, 5 times 2 is 10, so let's try it. I have 10 times 1 is 10. 1 times 2 is 2. 10 divided by 2 is 5, or 5 over 1. All right, my fifth grade friends, if we take a look at page 129, you'll see that we'll be doing practice problems number 1 and 13. The directions say, write the product. Write your answer in simplest form. Some of them might be a whole number, some of them might be a fraction, or a mixed number. If you have any questions on how to multiply fractions and whole numbers, please let me know when you come to class.